Students, okay, this morning we want to look at, we want to quickly look at television and gradient, divergence, and core. Gradient, divergence, and what and core. Now, before I start, gradient can also be referred to as grad. The such form of gradient is grad, while divergence is div, and what's core is still core. These three terms are related. Words are related. Now, gradients, when you find a gradient of a scalar, the answer will always be a vector. Why div? This is a scalar quantity, a scalar functions. Div is a what? Is a sorry. Gradient is a vector quantity. Div is a scalar quantity, and y call is also a what? A vector quantity. Now, given a scalar function phi, and if you are asked to find grad phi, grad of what? Grad of phi. Grad of phi is always equal to grad nabla phi. And nabla is defined by I di x plus g di y plus k di z dot what? Your phi. And when you use phi to open the bracket, you have I di x phi plus j di y phi plus k di z phi. Now, let's quickly look at one example here. For instance, you are given that phi equals to 2s squared y cubed z raised to the power 2. And you're asked to find grad phi. You have to find what grad phi. Now, how do you find grad phi in this particular word question? That is, given that phi equals to this, find what grad phi. All what you need to do is same thing as what we have here. But instead of your phi here, we replace it with 2s squared y raised to the power 3 z raised to the power 2. Meaning that if you are to find grad phi, that is nabla phi now is going to be what? I di x. What is your phi? 2s squared y 3 z squared plus j di y. What is your phi? 2s squared y raised to the power 3 z squared plus k di z. And what's your phi again? 2s squared y 3 y raised to the power 3 z raised to the power 2. I just simplify this. And we have I, you differentiate this to respect to x, meaning that you only differentiate towards 2s squared. And when you differentiate 2s squared, you have what? 4x y raised to the power 3 z raised to the power 2 plus j open bracket. Differentiate this with respect to y, meaning that you only differentiate y. And when you differentiate y raised to the power 3, you have what? 3y squared multiplied by 2s squared z squared, and everything becomes 6s squared y squared z squared plus this other one. You differentiate it with respect to what? Z, meaning that you only differentiate z here. And when you differentiate z, you have what? 2z multiplied by what? 2s squared y what? Y raised to the power what? 3. And when you multiply that, you have what? 4s squared y raised to the power 3 z z. And that will be your what? Answer. That is all about what? About gradient. That is grad. And when if you look at this our answer here, you see the answer is given in what? In vector format. and this IGK. Okay, and that is why we said grad is a what? Is a vector quantity. Now, quickly, let's look at divergence. Divergence. Now, divergence is like, for instance, let f, vector f be given as f1I plus f2j plus f3k. And you want to define div f. Div f is something as nabla multiplied by what? Vector f. And nabla is defined by I die x plus j die y plus k die z. Okay? Multiplied by what? Your vector what? F. And this one is something as I die x plus j die y plus k die z multiplied by what? Your vector f. And vector f is what? F1 I plus F2 j plus what? F3 k. Now you now multiply. But remember that I equals to j equals to what? K. Everything is equals to what? 1. But anytime you have I multiplied by j multiplied by k, and k multiplied by I, everything is equals to what? 0. Meaning that here, this one multiplied by this, we can have an answer to have die x f1 plus die y f2 plus die z f3. This is definition of what? Div. Now, quickly, let's look at one example under div also. Now, for instance, you are given that f vector f equals to x y I plus y z g plus x z k. Find div f. How will you simplify the solution? Let's quickly do this. Solution. We have what? Div f equals to nabla multiplied by what? Vector f. And based on what we defined the other time, we have nabla is I die x plus j die y plus what? K die z multiplied by what? Vector f. And vector f is xyi plus what? Yzj plus what? Szk. K. Now, and from here now, we just multiply, or you just open the bracket, and like I tell, this is all multiplied by this, we have an answer that die x multiplied by what? Xy plus this and this, we have what? Die y with what? Yz plus die z. This with this, we have what? Xz. Now, differentiate this with respect to x. You only differentiate x. And when you differentiate x is 1. 1 multiplied by y, we have what? Y. Plus. Differentiate this with respect to y, you only differentiate y. When you differentiate y is 1. We have what? Z. Plus. The last one, differentiate with respect to z. And when you differentiate z is 1. 1 multiplied by x, we have what? X. Meaning that your answer is what? X plus y plus what? Z, and which is what? Scalar quantity. That is all about div, that is divergence. And we can see here that your answer is in what? Is a scalar what? Scalar functions. It's a scalar function. Now, quickly, let's look at the last one, which is what? Call. Call. Call, as I said the other time, call is a what? Is a vector function. And the call is a function which functions, for instance, also, we can say let f or v be equals to what? Maybe v1 plus v2j plus v3 what? 3k. And you want to define call of what? Call of vector v. Vector v. Call of vector v is the same thing as call of vector v is same thing as nabla cross product with what? Vector v. And this is same thing as die x plus j die y plus k die z plus what's your vector v? v1 plus v2j plus v3 what? K. And for you to simplify this, if you can remember, you have what? I, J, K. And the first thing here, you have what? Die X, die Y, and die Z. And what's your vector I? We have what? V1, V2, V3. What the loss of this? That is determinant of what X. That is called. And you can simplify this, the no determinant. How do you simplify this? You have I, you cover this side, you cover this side. You are left with what? You are left with X. And first and foremost, this one multiplied by this, we have what? Die, open brackets, die Y, multiplied by V2 minus this one multiplied by this, you have what? Die Z, V, sorry, this one's supposed to be V3, V3, V2. Minus j, because if in any matrix we have plus minus what? Plus minus j, open brackets, you cover this, meaning that this multiplied by this other one, die x v3 minus die z, this one multiplied by this v1. The last one plus k into cover this, you are left with what? Die x v2 minus die y v1. And that is the core of what of v. Now, let's look at one example under this. Now, example, given that v or f vector f is given by s squared minus y squared r plus 2xyj plus y squared minus syk. Okay, and we have to find call f. How will you find call f solution? Now, based on the definition, call f is nabla cross product with what? Vector f. And quickly, don't waste your time. I just write I, J what? K. Now, we have what? Die X. Die Y. Die what? Z. And what's coefficient of I? We have what? X squared minus Y squared. Coefficient of J, 2xy. Coefficient of K, y squared minus xy. Okay, and just simplify this. Just what? Simplify this. A minute, please. Now, how do you simplify this? From here, we have I, open brackets. You cover this, you cover this. This is almost multiplied by this, minus this is almost multiplied by this. Now, first and foremost, you can just differentiate what you have here with respect to what? Y. And when you differentiate y squared, you have what? 2y minus. Differentiate minus 2y with respect to what? Y. You only differentiate y. And when you differentiate y is 1. 1 multiplied by this, you have what? Minus x. Minus. You know, if you remember when you have A, B, C, D, if you want to specify this, it's always what? AD minus BC. Leading diagonal first minus the other diagonal. Now minus, we differentiate this with respect to what? Z. And since this is not a function of Z, when you differentiate this with respect to Z, you have what? 0 minus J. Because there is always plus minus what? Plus. That is why we have minus J open bracket. We cover this, meaning that you differentiate what you have here with respect to X minus you differentiate what we have here with respect to what? Z. Now, when you differentiate what we have here with respect to X, differentiate Y squared, you have what? 0. Differentiate this other one, you have what? Minus Y minus. Differentiate this one with respect to Z. And since this one is not a function of Z, when you differentiate this, you have it as what? 0 plus k open bracket. You cover this. Differentiate this one with respect to x, you have what? 2y minus. Differentiate this one with respect to y. You have it as what? 2y. And from here, you can simplify further, and here you have what? 2y minus x I. This one multiplied by this plus what? Y what? Yj. And 2y minus 2y is 0, meaning that this is the final answer. And that is called F. Any question? Okay. Now, quickly, let's look at one or two examples again. One or two examples again. Now, example one. Okay. Let's, or given that vector f equals to vector f equals to y minus z plus 2i plus yz plus 4j minus xzk. Find df. That is question one. And question two, grad f. Solution. How to solve this? The first question we have to do here is what? Div what? Div f. And div f is what? Sorry, it's not I. The f is die x of what? F1, if you can remember, plus what? Die y, F2 plus die z, F what? 3. These are F1, this is our what? F2, and this is our what? F3. Meaning that from here, this is what is simply as die x. What's the x1? Y minus z minus. The question is y minus z plus 2 plus 2 plus die y z plus 4 plus die z of minus xz. Now, all what you need to do differentiate. Differentiate this one with respect to x. And since these ones are not the function of s, everything becomes what? 0. Plus differentiate to respect to x. Sorry, y. And when you differentiate to y with respect to y, we have 1. 1 multiplied by z, you have what? Z. Differentiate the constant is what? 0. And this last one, differentiate with respect to z. Differentiate z, you have 1. 1 multiplied by minus x, you have what? Minus what? X. Meaning that your answer here is z minus what? Minus x. That is your df. And we can see here that your answer is what? Scalar. Okay. Now, the second one is what we have to find call what? Call f. Call f is what? Nabla cross product with what? With f. And how to simplify it? You just have what? The determinant of what? I, j, k, die x, die y, die z. And from here, what's coefficient of I? Now this is your F1. Your F1 is what? Y minus Z plus 2. Coefficient of Y, we have what? YZ plus 4. And the last one, coefficient of what? Your F3, which is minus SZ. And now to simplify this, we just have I, open brackets. We cover this, cover this like this, cover it like this. Now, you differentiate what you have here with respect to y minus, you differentiate what you have here with respect to what z. Now, when we cover this and cover this, when we differentiate this with respect to y, what is the answer? The answer should be what? 0. Why? Because this one is not a function of what? Y. 0. Minus, you differentiate this one with respect to what? Z. And z is here. When you differentiate z is 1. 1 multiplied by y, we have what? Y. And when you differentiate 4 is what? Is 0. Minus j, open bracket. You cover this, you cover this. Differentiate this one with respect to what? X. When you differentiate this one with respect to x, you have what? Minus z. Minus z. Minus, you differentiate this one with respect to what? Z. And when you differentiate y, you have 0. When you differentiate 2, you have 0. When you differentiate minus z with respect to z, you have what? Minus 1. Plus k, open bracket, cover this. Differentiate this one to respect to x. Since this one is not the function of x, we have what is 0 minus. You differentiate this with respect to what? Y. When you differentiate this with respect to y, you have what? 1. Okay? Now we open the bracket here, you have minus yi plus zj plus j minus what? Minus k. And you can also write this as minus yi plus z plus 1 is common. J is common to them minus what? Minus k. That is your final answer. And we can see that this one is also what? A vector what? A vector. And that was why I said the other time, when you perform, anytime you perform diff operation, your answer will always give you a scalar. And when you perform core function, operation, your answer will be what? Vector. I do hope you understand it better now. Thank you. We'll see you next class. Okay, let's look at another example. Now, this is just called, for instance, you are given that f equals to 2x minus y I minus y z squared j minus y squared z k. We have to find or compute call f solution. Okay, solution. Now, how will you solve this? Call f. Call f is same thing as what? Nabla cross product with what? With f. And that is what? I, J was K. Die X, die Y, die what? Z. And your F, that is F1, F2, F3. These are F1, F2, F what? F3. That is what? 2x minus y minus yz squared minus y squared z minus yz. Okay, and you simplify this. And now to simplify this, we have what? I, open bracket. You cover this, you cover this. Now, you differentiate this with respect to what? Y. Okay, and when we differentiate this with respect to y, we have minus 2yz minus. We differentiate this one to respect to what? Z. And when you differentiate it to z, you also have what? Minus 2yz. Minus times minus is what? Is plus. Okay? Plus. And we close the bracket here. Minus j, open bracket. You cover this, you cover this. This one multiplied by this, you differentiate it with respect to x, and which is what? 0. Minus. Differentiate this one with respect to z is also what? 0. Plus j into, you cover this, you cover this. Differentiate this one with respect to x. You have what? 0. Minus. Differentiate this one with respect to y. You have what? Minus. Differentiate this one with respect to y, you have what? 1. Okay? And from here, we can see this one plus this is what? Is 0. This one is also 0. And this is positive, meaning that your answer will be what? J. Okay? And it's also what? Vector. Thank you. We'll stop here for today. Thank you. God bless. Bye-bye.